Use one trigonometric value to find the others. Now, before we really get started here and see what we got, let's do a couple of things. I want to get SOHCAHTOA because I'm dealing in right angle trigonometry. So I got a good reference point. And the second thing I want to do is I want to sketch some kind of right triangle. It doesn't have to be to scale. It doesn't have to be pretty. I just want to get some kind of, well, I can't even draw a period. There we go. All right, so I got a right angle here, and let's say that this is theta. All right, I want to locate, of course, my hypotenuse is directly across from the right angle. So let's see, if the tangent of theta is 1/2, so tangent is opposite over adjacent. So that means that this side is 1, that's the opposite side, and that's the adjacent side is 2. Find the exact values of the 5 remaining functions for the acute angle theta. Well, we might as well just go with the cotangent of theta because that's pretty easy. It's right in front of my face. So if the tangent of theta is 1/2, the cotangent's the reciprocal of that, or 2/1, or just 2. Now, let's see, my sine and my cosine, my cosecant, and my secant functions all involve the hypotenuse, and I don't yet know that measure. But I can find it using Pythagorean. A squared plus b squared equals c squared, where c is the hypotenuse. And let's substitute in 1 squared plus 2 squared equals c squared. Well, let's see, 1 squared is 1, 2 squared is 4. So c squared equals 5. And then if we take the square root of both sides just to find c, then we say that the hypotenuse is the square root of 5. All right, it says find the exact values. That means there's no rounding. We've got to just stick with this square root because it gives us an exact value rather than some kind of rounded of a decimal. So let's see. Then the sine function, let's work on the sine function. So the sine of theta is going to be the opposite side, which is 1, over the hypotenuse, which is the square root of 5. Now, as we know, mathematicians have an aversion to leaving a radical in the denominator, so we're going to rationalize that by being the square root of 5 over square root of 5. And let's see, 1 times the square root of 5 is the square root of 5. And the square root of 5 times the square root of 5 is 5. So the sine of theta is square root of 5 over 5. While we're here, let's just go ahead and do the cosecant of theta. And it's just the reciprocal, and I can just use this value here, the reciprocal of that, before I rationalize it. And so the cosecant of theta is the square root of 5 over 1, or just the square root of 5. Now, how about the cosine? Well, the cosine of theta is the adjacent side, which is 2 over the square root of 5, hypotenuse. And again, I need to rationalize the radical by multiplying by the square root of 5 over 5. And so the cosine is going to be 2 times the square root of 5 over square root of 5 times square root of 5 is 5. All right, well, last up is the secant, which is the reciprocal of the cosine, and I can use that particular value right there so that my secant is the square root of 5 over 2, and shazam, we've been given a tangent function. We put SOHCAHTOA at the top, give us a reference point. We drew a right angle, labeled it, realized we had to find the value of the hypotenuse. We used Pythagorean theorem to do that. A squared plus b squared equals c squared. And then we just proceeded in finding the exact values of the 5 remaining trigonometric functions, and we are wonderful.